We're going to be classifying a recurrence relation by homogeneity. So in the previous two lessons, the first one we classified by order, the second one we classified by linearity, and in this one we're going to be classifying by homogeneity. Now the order, we said it was the maximum subscript minus the minimum subscript. Linearity is when y subscript k, or the independent variable, appears only once in all terms, not in one, not in two, but in all terms. Homogeneity is when your function of the independent variable is equal to 0. So we'll see that as we go. So now let's have in the first example. Now let's give a basic example of f of x is equal to x squared minus x minus 12. Well, this function here, if I let the function in x to be equal to 0, then I am going to have x squared minus x minus 12 being equal to 0. If I have this, then I say my equation is homogeneous. So when you're solving the roots of this equation, you solve the homogeneous part of the equation. So basically, you equate your function of the independent variable to 0, and you get the homogeneous equation. Now, if we say to you now, y sub k minus 3, y sub k minus 1, minus 4, y sub k minus 2 equal to 0, where this is some function in k. Now you see what we have here. We have the expression being equal to 0. Therefore, we have the right to say that that equation here is homogeneous. But if we say y sub k minus 2 plus y sub k minus y sub k minus 3 equal to y squared, right? Let's just say y squared. It can be anything this side, doesn't matter. Now, this is your function in k, and it's not equal to 0. You can see that this difference equation here, y sub k minus 2 plus y sub k minus y sub k minus 3, is not equal to 0. Therefore, that relation over there is non-homogeneous. So we classify order by taking the maximum, index, and the minimum. We classify linearity by examining how many times the independent variable y sub k appears in the expression on all the terms. We classify homogeneity by examining if the function of the independent variable is equal to 0. If not, then you conclude that it is nonlinear. Now, I need us to combine all these things now. Now, let's say I give you y sub k plus 2 minus y sub k minus 3 minus y sub k equal to 8. So this is just a hypothetical for illustration purpose. Now, what is the order of this recurrence relation? Is it linear or not? And is it homogeneous or not? Well, feel free to pause and try it on your own. Now, the first one we're going to look at is order. Now, the order is equal to the maximum subscript minus the minimum subscript. The maximum subscript here is y subscript k. Now, is this index here? Actually, it's this one. Okay, so k plus 2 is more than k, right? We agree on that. So the maximum is k plus 2 minus the minimum, which is k minus 3. Then I'm going to have k plus 2 minus k plus 3. K will cancel k, then I get 5. Then it means the order of this recurrence relation is 5. Is it linear or not? Well, y subscript k appears once here, only once there, only once there. Therefore, it is linear because we see yk once in all terms. Is it homogeneous or not? You look at the right hand side. RHS. Function of k is equal to 8, not equal to 0. Therefore, conclusion, it is non-homogeneous. So this is how we can classify a recurrence relation by order, linearity, and by homogeneity. Thank you for watching.